welcome Dinorah to the series. I was looking through the work, and there's a lot of resonance with the work that Dinorah does and the work that goes on here at the Stickman School in the Department of Architecture. And I think you'll see that. The work you do, Dinorah, is amazing, so important, beautiful, but also part of these past traditions, but also asking what we can do with new material, thinking about material in a different way, but new tools and technologies as well. So I think you're going to enjoy what Dinorah has to talk about. To give a proper introduction, I'm going to hand it over to Orsholia Gaspar to introduce Dinorah. Thank you very much.
Welcome everyone, and special welcome to Dinorah. As you will see, she is not only multi-talented, but she's also very accomplished. So Dinorah Martinez Schulte is a Mexican architect and researcher. She graduated in architecture with honors from the Cátedra Blanca CEMEX with the thesis Sutura Topográfica from the Universidad Iberoamericana, Mexico City. She received the Manuel Garibay Award for her thesis, and the project was also nominated in the MCHAP Student Award in 2016. In 2019, she was awarded a scholarship to participate in Norman Foster Foundation's Robotic Atelier. She completed her postgraduate master's program in advanced studies in architecture and digital fabrication at ETH Zurich in Switzerland. Schulte has collaborated with renowned firms such as Mad Architects in China and Ensemble Studio in Madrid, Spain. Currently, she's based in Mexico City, and she's the co-founder and principal of Manufactura. This is a multidisciplinary research and production design factory that studies the relationship between analog and digital fabrication through innovation based on tradition, and this provides new alternatives to meet a sustainable built future. Her praxis is unique in the sense that she actively mixes research and design, and I think that you all will find that super inspiring. She's an adjunct professor at the Universidad Iberoamericana and the Universidad La Salle in Mexico City. She's also a member of the editorial board of CEMEX Mexico 2023. Recently, she was selected at the Open Studio Residency for 2024 for this year at Haystack Mountain School of Crafts at Deer Isle, Maine, US. I encourage all of you to check her Instagram for the work she has done there and all other work she has. Her research focuses on promoting cultural exchange through technology to explore the impact of digital fabrication in Mexico. As a sustainability and innovation enthusiast with vast experience in Latin America, she diligently works to create sustainable solutions while preserving the country's rich cultural heritage. She challenges vernacular manufacturing systems and embraces circular, locally sourced materials through digital fabrication and material innovation. And with that, the floor is yours, Dinorah. Warm welcome, and please enjoy.
Hi, good afternoon. Thank you so much, and good afternoon from Mexico City. I'm based here. I live here since 2022. I want to thank you, first of all, to Marcus to look for me and to get in touch. Thank you so much for this invitation, and also for Penn State University to make me this space and give me this voice to share my practice of digital fabrication in Mexico. I will share my slides. So practice in Mexico is not totally the same as in US, in Australia, or in Europe. It's totally different. Like right now here, what we are doing is crafting tradition through innovation. So as you mentioned, no, I studied digital fabrication and robotics in ETH Zurich, and here in the university, I had the opportunity to work with different kind of materiality, like plastic, metals, earth, concrete, textiles, and others. So I will explain a little bit each material, because every project is totally different, and also the material behaves totally different in each project. So the first thing that we did is 3D printing with PLA plastic in part of the MIS, no? Part of an exercise called eggshell bricks. So in this case, for example, we started to play with plastic, with the size, with the geometry. And one of the good potential of plastic is like plastic dries very fast. So you can also play with the definition, with the texture, with the scale of the products that you are doing. Secondly, in 2019, I get the robotic atelier by the Norman Foster Foundation. So we also 3D print with plastic, but in this case, the plastic were recycled from the oceans. In this case, well, this is the project that I talked before. Sorry, there was a little bit mess. But in this case, you can see plastic. We use the plastic as a formwork for doing bricks, and then we cut concrete inside. So one of the good benefits of plastic, you can also play not just with the definition, you also can play with the texture and with the aesthetics of this kind of plastic. And in this case, for example, we connect one part of the brick with the other, and then we create a translucent brick that we can transport the light from every size of the brick. So in the robotic atelier, one of the main topics were facades. So Norman Foster said that we need to be really sustainable, not just in terms of materiality, we also have to take care about transportation and easily installation in the site. So in this case, there were three teams like thermal insulation, natural ventilation, and natural water. So in my case, I had the project with natural insulation. So in this case, we create these projects or these products by two curvatures that they merge each other. And then you can also connect and replicate these elements from one of the top, no? Or also you can replicate it and they can be connected one in the other side. So in this case, you can see what is the potential of data fabrication that you can also create one product or one prototype, and then you can replicate it many times and do a mass production, but you can also customize this kind of products. And in this case, we also leave the empty space in the interior because we want to, for example, if we have a very hot weather, you can add, no, you can leave it open, and then these products can start to create an empty space between the exterior and the interior, and then you can regulate the temperature in the building. But then if you have a very cold weather, you can also add, no, like thermal insulation inside, and then you can create like a very big gap between the interior and the exterior. So another project that we also 3D print with plastic, where this project calls Digital Bamboo Pavilion. It's a very big pavilion that we do also in the MIS in ETH Zurich. And in this case, one of the really big challenge is 3D printing in textiles or fabrics. So this is the pavilion, and the pavilion is built by three systems. So the first system is the textiles on the top, then the bamboo structure, and then the joints. So there are three construction systems working in the same time. So first, I was in the fabric team, and in this case, we studied different kinds of fabrics, for example, to see which one is better for printing. So in this case, 3D printing allow us to do this, to start to get different kind of hierarchies or different kind of orders in the 3D printing. For example, if you want a more structural performance, you need more levels of printing. So we have very thicker printer like elements like this. And then if you want more like aesthetics or like a drawing, for example, these ones, then you need a very thin layer of printing. So also the second system was the joints. The joints were with binder jetting, with nylon, and nylon it's a very strong textile. So for example, we use this system to knit or to connect every bamboo elements and very easily system. For example, you can join it with the 3-zip tight, and then you have a hole, you put the bamboo inside, and then you put the cap, and the system is done. So we also were thinking about like to creating very easy assembly system because we were students and we are not really a specialized construction. So we want to create this pavilion to be easy to be assembled and disassembled on site. For example, this one is the principal knot that is in the middle of the pavilion, and this knot is also made by metal, but in this case, the metal was totally optimized with topology optimization. So if you don't know what is this, we are optimizing the quantity of material that we have in the element, and then we just replace or reduce the quantity of material in the element. So this is the construction system, and then you can see the node, no? So we have these two bars, and in these two bars, we do the hole in the bamboo stick, and then we put it inside, and then we add a cap, and then pre-zip tied. And that was a very easy construction system. So it allowed us to construct this pavilion, for example, in very limited time of 2 days. In 2 days, we construct this pavilion, and also we disassemble this pavilion. So this pavilion was very easy to assemble and disassemble. So we also transport, for example, in this case, we exhibit this pavilion in the Museum of Architecture in Zurich. And thanks to technology and thanks to computational design, we can create this kind of aesthetics that we can use algorithms and parameters, no, to start to design, no, with digital fabrication. And also, you can see, for example, this is the view from the bottom, the bottom of the pavilion, and you can see the tree system working together, the bamboo, the textiles, and the joints. So one of the big challenges and objectives of this pavilion is to see what is the best performance in terms of structural performance of natural materials like bamboo. And then we can see we can create a canvas or big structures without columns more than 1 meter. And this pavilion were exhibited also in the Venice Biennale in 2022, I think so. So it was very easy to transport it. Then the second material that we work is concrete. We 3D print with concrete, but concrete is totally different. We did this exercise called concrete calligraphy. And in this case, we do these big facades, no? And in these facades, every student started to select a very different topics. For example, these curvatures, or for example, shading or natural lighting. So in this case, concrete is not the same like plastic. It's totally different. Concrete didn't dry. Concrete is started to get strength by the time in 72 hours. So the concrete is not really fast to dry. So we have to take in consideration these kind of things. Other thing that concrete have a very thick layer. So for example, it's about 1 or 2 centimeters of thick layer or of thickness of layer. So we have to take in consideration these kind of conditions that the material is started to tell us to start to design the elements. So for example, in this case, we started to design this kind of facade that in the joints or in the nodes, all the elements started to join. And then also concrete, you cannot stop at 3D printing concrete. Why? Because it's totally liquid. So you have to also take in consideration that you have to create a continuous line design. So in this case, we do this replication of the facade, and then we select, this is the final picture of the facade and how it works. And for example, we started to take in advantage the nodes for assemble one element with the other element. So this is the final result, and then we just select one of this element, and then we just 3D print. Other thing that you have to take in consideration with 3D printing is that 3D printing with concrete have a very rustic or very raw aesthetic. So you are not allowed to do a good, how to say this, a good details. So you have to use curves and organic curvatures to start to get good results with 3D printing concrete. In this case, we do and extrude some faces, and in these faces, we can use the concrete as a table, as a library, like this, or as a window, and then we can connect the exterior and the interior of the building. Then the third material we worked with was earth. Earth is totally different than concrete and plastic, and I want to mention something about earth. Earth is not a systematic material. It's totally organic, and it's really related with the location that you are based on. For example, if you're based in Mexico, the ingredients of the components of the earth will be totally different than in Europe or in Asia or other kind of location. In this case, we do this rapid clay formations pavilion. It was also part of the master degree. And in this case, we take in consideration the machine force and the machine labor to start to knit this wall with air bullets, no? In this case, for example, we were thinking to install or doing an installation of this pavilion, first of all, in Brazil. in an architectural festival. But unfortunately, COVID was passing in this time, so we have to change the location, and we started to study the air from Switzerland. That is completely different. So what we started to do, we started to find this kind of thing. And this is not an error. This is the naturality of the material that is saying to us that the quantity of the material or the quantity of the components is not the right for this kind of material. So that's why we started to study different kinds of components, that quantity of water, sand, air, and other things of to select the most optimized material or mix to, in this case, to start it to knit in the pavilion. So this is the quantities, no, and the different like comparison of the mixes. And then at the end, as you know, robotics or the robots have a very limited working space. So we need to be very careful about this because you cannot 3D print in a very infinite space. You have a very limited space. So what we do is started also to plan a different strategy, no, to think about the position of these parts of the wall. So in this case, this project started, well, after the MIS, we didn't finish the project. So Gramatze Color Research, that is the research group that it was leading us in this project, they started to do this as a professional project. It calls Clay Rotunda, and this is the final result that they did. You can see how these sections, no, if you see my course, or the arrow, you can see how the different kind of stages of fabrication started to be placed in the whole wall. The whole wall was not printed as a monolithic element, was printed in different kind of discrete elements that they were needed. And we use also the force of the machine to avoid to use concrete or wood structures inside the wall, and the wall didn't have any structure. The structure is totally given by the earth. So, and the last material that I did in the MIS, it was mineral foam recycled by inorganic waste. So in this case, one of the things, as you know, we are responsible of the 40% of the CO footprint, and we need to realize and we need to do some changes in terms of fabrication, but also in terms of materiality. We need to start it to fabricate with new materials that they can be more friendly with the environment. So in this case, I put in the table this kind of languages in the architecture or typologies, that is la celosía, that we call this the lattices. The lattices in Mexico, they were very useful because we have a very climate that you can be able to open the spaces a little bit and create a microclimate in between the interior and the exterior of the building. So in this case, for example, I like this image because you can see one building element that is the concrete block, you can see here, and it's performing about everything. It's performing as the support of the bed, it's performing as a wall, it's performing as a window, it's performing as everything in the space. So detail fabrication allow us to transform and to adapt these construction elements like the brick to different kind of behaviors. For example, if you want to use natural ventilation or natural lighting or whatever, the different kind of situations that we have in the built environment. So in this case, I divide my thesis in different kind of stage: the design of the project, the study of the material, and then the fabrication method. Talking about the fabrication method, I print in 10 minutes. Then I let dry these pieces in 48 hours. That is a lot, that is almost 2 days. And then we put in the oven in a very low temperature of 1050 centigrades in a time of also 2 days. So printing and fabricating one brick of this material, it took me more than 5 days. So in this case, this is how the material looks like after the printing. And then you can see it looks like earth, but it's not earth. It's a foam. It's mineral foam, as the soap foam that we use all the days, no, to wash our hands. This is the same. And you can also see the porosity in the holes, no, that the material is producing in the whole geometry. Then after the firing process, then we have this color. It looks like clay, but it's not clay. One of the benefits of using foam instead of clay is you have a very low density. So all the elements are very lightweight. So this is my fabrication tools that I have: the robotic arm, the material extruder, and the printing bed. But one of the important things about this project, the material extruder is not moving. It's totally static. The space moving, or the tool that is moving, is the printing bed. that is totally different because the printing bed, when it's moved, the whole geometry started to move. So I did this geometry matrix that is very basic now, instead to started to test which geometry or which geometry direction works more efficiently with this kind of material. I did this matrix with the squares, with triangles, with circles, and with also with curvatures. So I did a prototyping of different kind of elements, strategies, and geometries in a whole month. It was in June. And I started to print, as you can see in the first image now, the whole geometry. Then I started to print just the perimeter, but the problem was the walls started to taper in the interior. So I realized that I need an internal infill or internal structure to get more stability in the bricks. So I started to do a square infill, but then it didn't work very well. So I changed it to a circular geometry. So one of the first objectives of this research was, how can I get the best quality of printing? So as you can see the fabrication matrix, you can see the layer height, the layer width, the robot speed, the foot rate, and I started to change these parameters to get the best result. Then I find this. This is how the material started to behave and started to work. The first layers started to be very splashed, and after the layer 3, the material started to expand because it's a foam. So I have to start to design with this material condition. So the second objective was how can I get the best or the better height in the printing bricks? So first of all, I started to print only the perimeter, and then I realized I cannot get 10 centimeters. That is nothing. So I did different kind of interior infills now to create a better structure in the bricks, as double wall, that is the first one, then square geometries, simple infills, and then curvature infills. So at the end, I also tried to print a little bit outside the printing pad, and it was not possible because the material do not allow to do this. So at the end, I just compared the physical properties now of each geometry, for example, the square pad, the circle pad, the metal pad, and the curvature pad. And at the end, I compare the weight, the volume of the material wasted, and also the printing time. And if you can see, the last geometries, as the metal and the curvature, use a lot of material, almost all the cylinder, and also have a lot of time of printing, almost like 15 minutes. It was not really optimized. So at the end, I selected now the circle and the square, and if you can see, they only use 8 or 10 minutes of printing. So at the end, we realized like circle was the best geometry that can work with this with this material. So we started to do two kinds of applications or architectural applications. But then when I was printing, I realized two things. First of all, if I don't flip the bricks and I just stack it each and another, no, I can get a wall. That is the first architectural application. But if I flip the brick, I can get a screen. So first of all, I studied the first application, that is the wall. And for example, in a wall of 2 meters and 1 meter, I use 200 bricks. And this is how it looks like in architectural space. For example, I was able to use natural lighting and to also allow natural ventilation. But the problem is it's a lot of bricks and it's a lot of time and it will take me a lot. So the second application is the screen facade. So the screen facade of 2.5 meters and 1 meter, I only use 24 bricks. So 24 weeks was more optimized than my times that I have. And this is the final output or the final demonstration that I did now as a master thesis. And for example, as I mentioned, this is a foam, it's not clay. So in this case, the foam started to be very light and then reduce the kind of weight that I have in my final facade. So this facade, it only weighs 15 kilograms. That is nothing. I can carry it with my hand. So this is how it looks like. And I also was creating a microclimate in between the interior and the exterior. So this is how you can also complement or control the diameter of the circles to create more noise or less noise, depending the privacy that you want to create in the space. So one of the details is if the bricks are smaller, then you can get higher. But if the bricks are bigger, you can get less higher. So this is how it looks like. This is how I was working this material in terms of optimization. And then at the end, I create my goal that I want to create a material and then an architectural element that can allow me to control the natural ventilation and also to create a microclimate in between the interior and the exterior, as the lattices, as las celosías that in Mexico. So I only not work with digital fabrication and digital tools, with digital materials. I also work with my body. So I also work in Ensemble Studio in Madrid, and I did this furniture for this pavilion called Domo, that is in Montana, in United States. And in this case, if you can see, if you know Ensemble Studio, it's a studio that I really highly recommended to research because they are creating architecture in a very radical way. They don't start in a very traditional way, like doing the plans and then the model, then the structure, and then the construction. No, they build the models by hand, and then with 3D scan, they started to create new forms and new materiality in architecture. So in this case, we have to create the furniture for this pavilion because this pavilion creates different kind of events in the interior. So I used this, I needed totally by hand, no, my hand was very tired in this time. I needed all the furniture by hand, and also we use a fabric of concrete. This fabric have a lot of very big amount of concrete, and then if you use water, then you can model it by hand because the fabric started to be very light and very suitable to allow to you that can create your own geometry. So in this case, this is how it works. We put a formwork, for example, a chair or a normal geometry. Then we put the fabric on top, and then we use water to modeling by hand. And modeling by hand have something also very calm, very magical, because you use the intuition of your body. These kind of wrinkles that we get in textile is something that maybe the machines cannot do. So I love this picture because after doing this project, I use digital fabrication to create other kind of outputs. For example, in this case, all the people will think I did the geometry in Grasshopper, and then I just 3D printed and then just fabricate by hand. But no, I did first the project by hand, no, the furniture, I did the wrinkles by my hand, and then I used technology to create another kind of output like CNC milling or 3D printing. So in this case, I just reflect about what happened if an analog design with technology and 3D scan, you can create different outputs of digital fabrication, as you see, no, like subtractive manufacturing, like CNC milling, or additive manufacturing as 3D printing. What happens if we do the inverse? What happens if we create a design totally digital in the computer, and then we have to fabricate it analogically, so, or by hand? So this relationship, I started to reflect about this relationship at the gap in between different kinds of fabrication. So this is how I came back to Mexico in 2022, and I found Manufactura. So Manufactura is this, it's innovation based on tradition. Other thing that I listen a lot in Switzerland is like they were celebrating that humans were replaced by machines. And this is something that in Mexico is totally violent. And I will explain why. That's why we don't create that machines should replace humans, as in the Industrial Revolution we thought. And I think we should complement each other. That's why we want to answer to the different problematics in construction in Mexico. The first one, as we know, we are the responsible of the 40% of the CO food emissions, no, of the construction sector. The second, and this is very particular in Mexico, is the fair labor conditions. In Mexico, every 75 seconds, there is an accident occur in the industry of construction in Mexico. Why? Because most of these people do not have access to medical insurance, to good security equipment, so they are really risky their lives. And the third problem is the threat of automation of job replacement. Here in Mexico, there is a lot of threat because the people think we were going to replace by artificial intelligence or by machines. So in manufacturing, we want to redesign the way of making. How we want to do it? We believe in the use of technology for a future sustainable built environment. We want to build an innovative future based on the tradition, but principally we want to develop dialogues among digital fabrication and humanity. So we really believe in the conscious use of technology for creating a future sustainable built environment. We are based on Mexico City. And if you don't know Mexico City, I totally invite you. It's a very interesting city here in America. And we are also based in Dr. Lucio 180, no, in Colonia Doctores. Colonia Doctores, or Doctores neighborhood, it's a very common neighborhood in Mexico City of old factories. So right now we are based in a very old factory called Laguna. Laguna was a fabric or textile factory in the 20th century. And right now we are taking this to create a, how to say this, like a sharing space with different creative firms or studios, and also one of the studio is us. So in this project is made by Productora, and they want to also keep the essence of the factory. They don't want to replace it. They don't want to destroy it. They want to recycle it. So our equipment, we have a very industrial robotic arm, a KUKA 150, and this project or this tool allow us to get different kind of services like material developing, research projects with PhD students, for example, or with master thesis projects or commercial projects with different brands, and education. We also want to create a platform that provides democratized access to our community, offering information to the consumer technology. So what is our technology? We only have two kinds of technology: 3D printing, additive manufacturing, and robotic knitting. We also have this kind of knitting that they can be automated, but we are also using materials that were fabricated or made by artisans, by local artisans. And our material research, we do a classification of the waste in Mexico. And for example, more than the 60% of the waste there are organic waste that came from the food industry. Then paper and cardboard, then glass, plastics, and other kind of material. So that's why we separate our research of materiality in two groups: the local materials that we produce in Mexico, and then the circular materials. So the local materials, for example, local clay, air, talavera, and ceramics, they are like very related with the tradition of producing materials in Mexico. They are also part of our cultural heritage. And in the second group, the circular materials, they are made by food waste or organic waste, and then we just redo the mix to create a new biocomposite. So what is our process? We first of all develop the 3D printing material, then we have a geometry prototyping, and then we do the mass production depending the application that we will use. So our materiality are totally a donation from waste or local materials, that then we transform it in professional or different construction elements like bricks, lattices, or like bowls. In this case, for example, then we produce different kind of applications, no, in walls, in floors, or in ceilings, depending the construction system that they want to apply this kind of material. So the projects that I want to present to you, there are different projects depending. Well, we did a lot of projects in between 2002 and 2024. And the first project that I will present is this one, the actual project that we did in collaboration with Montserrat Ayala. And the question is possible to build with our waste? The answer is totally yes. Why we are using eggshell instead of other kind of organic waste or organic or other shell? Because Mexico is the one of the 4 producer of eggshell in the world, and is the first, the 5th consumer in the world. So we have very present the eggshell in our diet. That's what there is a lot of volumes of eggshell. And for example, what we do, we started first of all to study the material by hand, and then we digitalize it to apply this material for 3D printing. How we do it? We just crush and then sanitize the eggshell. Then we agglutinate with different organic binders. And after this, we create this biocomposite or bioceramic that can allow us to 3D print. We use an industrial robotic arm and an industrial 3D potter, no, extruder, and then we allow us to do a mass production. So in this case, you can see how it looks like now, the 3D printing with eggshell, and it's totally possible to build with our waste. So also one of the benefits of using eggshell in different, in comparison with other materials, you can also change the color depending the eggshell. If the eggshell is brown, then your brick will be brown. If the eggshell is white, then your brick will be white. And then you can naturally, without using pigments or artificial materials, change the color and change the aesthetics of the material. So also we do a different prototyping in different geometries to see what is the good dimension to print with this material. So this one was the selected because it was the most optimized geometry to use with this kind of materiality. And then the first demonstrator that we did, it was a first wall prototype did by 115 bricks. We also installed it totally by hand. And thanks to the geometry, they can be assembled each other without using steel bars. So this is the aesthetics of the action bricks. It's totally very beautiful. And also you can see the natural material not working in a virtual space. And yeah, this is the result, the final bricks that we did. This is the first demonstrator, the physical demonstrator that we also exposed it in Inédito in Design Week Mexico 2022. We also get an award of how to say this, innovation, material innovation. And then the second prototype, an art event that called Sonamaco, that is very important here in Mexico. They exhibit a lot of art pieces and they invite us to create an art piece. So I invited an artist from Germany that her name is Maria, and she was creating this column it was made by 30 different bricks. But the challenge here is not the shape and it's not the output. It's about changing the geometry of the bricks. We were asking if it's possible to change the brick geometry. So the answer is yes. It's totally possible. We change it from a rectangle to a circle bricks. And these, for example, are 13 different pieces, no? And they are connected by the infill that they are parametrically did. So they are also assemble each other, no? And then we can do from discrete elements a very big component. So actually, currently, we are studying now the performance, the structural performance of this material. Right now, the performance in terms of compression are very low. So right now, we are like mejorando, I don't say, like getting a better mix. Right now, we are formulating a better mix to get a better structural performance. So the second project is Sueños with Air and Concrete. We collaborate with the Digital Structures group from MIT, and then also with New Story and HLA. So in this case, New Story tell us what is the different or the typical materiality in the in the how to say in housing in Mexico. And for example, in this housing, we use earth, we use clay, and then they use concrete. So this pavilion was created with three different constructions. The first one is the two compressed air bricks that they form the two walls, then the ceramic hollow blocks, and then the precast rim. In Mexico, we call this bigueta and bovedilla. That is a very commercial and economical construction system. So in this case, we use the good of the benefits of digital fabrication to start to do different kind of geometries. No, in this case, we have to adapt the ceramic, the precast beam. We're changing the geometry. It started to get thicker in the middle and then thinner when it touched the walls. So we did 18 different kind of beams and then we reproduce it in a mass production. So one of the benefits of digital fabrication, you can adapt it very fast in 10 minutes or less, and then you can create different kind of shapes that they are totally different. So we collaborate also with Amphora Studio, that if you don't know who are they are the most oldest ceramic factory in Mexico. And then we use a mix in between two traditional clays, a clay from Oaxaca region and then a clay from Zacatecas region to get more compression strength. So in this case, we do this collaboration, and this is how the balls look like before the firing process, and after the fire, they get the terracotta color. So in this case, you can also see how it joins. You have a little piece of concrete that of 3 or 4 centimeters, and then the balls started to get there. So this is the different beam, no, that you can see. The curvature plays a very important role here because structurally it works better than a planar surface. So we create 200 pieces, no, and we install it totally by hand without replacing any human in Alameda Central in the downtown of Mexico City for an exhibition called Mextropoli. So this is the final result, and also it's a part of a PhD project from Eduardo and from Sandy Cord, that they are students, PhD students in MIT. This is the result, no? It's totally like possible to create different or innovative construction systems, but following the tradition. And in this case, this pavilion was installed in September, and September is this month is the earthquake month. So here in Mexico is a very big earthquake zone, so we have to be very careful. And when we were installing this pavilion, it shakes 2 times and nothing gets broken. So for us, it was a very good test, like that we did, no, naturally. This is the final pavilion. And then the third project that I'm going to present is the wood project. We collaborate with La Metropolitana. La Metropolitana, as you didn't know, they are furniture designers. And in this case, these guys are working with different kinds of traditional or local wood from Mexico. In this way, in this case, they were working with salam. Salam is a very natural material or wood that they are based in the south of Mexico, and it's a very good wood because it's very expensive, because it have a very good compression strength or also flexion strength. So in this case, we just create the same, or we use the same mix of the eggshell, but we just replace the eggshell from the sawdust. We use the sawdust. We also mix it, no, with the same biocomposites, and it's totally also possible to 3D print with sawdust. And also, La Metropolitana have a really big problem or issue with the sawdust. The sawdust, they have more than 500 kilograms of waste diary in the factory of sawdust. And also sawdust, it's a very unhealthy material because if you smell it, it's a very unhealthy material. So we want to create a product from their waste, and the material is totally donated. So the product started to be cheaper than the normal materials. So also when it gets dry, you can also see the aesthetics of the sawdust, and you can see how the material smells, how the material see, and how the material looks like. And also in these biocomposites, in comparison with the clay, we don't use a firing process. We use the sun to get it dry for 24 hours completely, and then all the bacteria or the organism started to disappear. So we put it on the sun, and that's a more sustainable way to save energy and also to save time in terms of fabrication. So we do lattices for an exhibition, and they are totally by electrical source. So the fourth project that I present is Azul Digital. I'm also a teacher in Universidad Iberoamericana, and we want to guess what happens if we add color, but not by glazing. That is, you need a double firing process. What happens if you add it from the beginning when you're using or we are producing or fabricating the mix? So in this case, we collaborate with Amphora, and we use this pigment that is called Azul Colonial, and this is our studio. This is my factory. And then we have a really big patio in this building. So we use it as the scenario, no? In this case, the students started to understand how this patio or how this space works, no, in terms of circulation, in terms of things that happens diary there. And then they started to do a floor system. This is a flooring system created by different triangles that they are assembled each another. So they did or fabricate 3 kinds of bricks: the A that is totally plain, then with curvature, and then with more curvature that is the C. So in this case, thanks to computational design, we can start to do a different configuration of these bricks in the floor, and then we can also play with the different elements. So this is the final result. We also create an earthen carpet, no? Because the concrete floor is very old and is very damaged. So we started to use this earth carpet. And then also one of the most interesting parts is the pigment. So how to create this kind of pigment? This is the normal natural color of the clay, no? Then we started to add the pigment in different gradients, no? The blue, intermediate, or light blue. And then they knead it by 20 minutes totally by hand. And then they just prepare this kind of bullets to create a more optimized and faster production, no? To fill the tube, to create a very fast 3D printing production. And then we can get it. We get the blue pigment, no, inside the normal ceramics since or through the material process. So when we printed, this is how it looks like. It looks like a little bit gray, no? But it's very blue. So we left to dry 24 hours. And then this is a picture that I really love because you can see how the bricks look like before the firing and then after the firing. So we have to be very careful with the quantity of pigments that we add in the ceramics, no? And also they tested, no, normally physically, no, to see if the floor system totally works. And this is the final project. Well, this project we did the last year, the Talavera project. This project, I want to be very careful because Uriarte Talavera, we did it in collaboration. Uriarte Talavera is the most oldest Talavera factory in the world, in Mexico, that it came 200 years ago. So what happened with Talavera? Talavera is not ceramic. It looks like ceramic, but it's not ceramic. The nomination of protected material by the cultural heritage, so by the government, so they cannot change the methodology to do Talavera. In comparison with ceramics, you can use any ceramic, you can use any oven, any materiality or any tool. In Talavera, you cannot change it because if you're changing, you're replacing the cultural heritage of Mexico. So I asked to them, what is the principal problems that they have? One is the innovation. They cannot innovate because they have to replicate the same methodology since 200 years ago. And the second problem is this, they have a lot of waste because this material is totally protected. So if the material or the product that they are fabricating get damaged or get broken or they have a little mistake, they cannot sell it. So they have volumes and volumes and volumes of ceramic or talavera trash it, no, and storage in spaces, no. What we do is what happened, like technology, they are trying to automatize, no, the humans. What happened if we humanize the machines instead of the machines automate us? So, first of all, it started with a very automated process that is 3D printing, no, that it's very automated. It's not totally industrial, but it's kind of an industrial methodology. And then by hand, this, for example, we reduce the kind of wrinkles that they have these products after the printing. And then an artisan that is totally certificated by this kind of technology or like Talavera, they replicate this geometry by a plaster mold, and then they replicate it totally by hand, following the next steps, that is the steps that we fabricate Talavera. So they did the mold with plaster, then we used two kinds of clay, a brown clay and a white clay, because the white clay represents the Spanish and the Europeans coming to Mexico, and the black clay represent the indigenous people in Mexico. So this clay, it's also an heritage of our mestiçage, of our culture. So we just burn it, no? And after the oven, Guadalupe, that is an artisan, she just remove all the things that they have. And then the glazing process. The glazing process is a very, like a very epic and different production, no? It's very traditional in Talavera because if Talavera didn't have the glaze, it's not Talavera. So after this artisan just reduce the kind of damages that the pieces have after the glazing, and then painting. The painting is one of the most interesting stages because we use the azul cobalto or the cobalt blue, that is the pigment that also represents the Spanish monarchy, that they came to us and conquest us. But also this methodology, this fabrication process is totally made by hand by a pencil that it came from donkey hair. They cannot just buy a pencil like in the I don't know, in the store or whatever. No, they have to fabricate the pencil with donkey hair. That is totally crazy. And then from an industrial process, a very controlled process that is additive manufacturing, we just humanize machines and humanize the technology, like also promoting, no, artisan work and labor, because here in Mexico, the labor work is disappearing. And also they have a really bad low income every month. So we need to improve, we need to promote the most. So this is the final piece, that the tower represent the innovation, because we use 3D printing to create the geometry and then to replicate it totally by hand by artisans. And then we just accompany this column with a really big carpet made by all the ways that we found, that actually this is not the total ways that we found, but it's one big quantity. And we want to also change the perspective about using this material waste for a new use of in design of architecture, and then the designers can change the perspective of Talavera. So this is the final pieces and the final color with the cobalt blue. And also was exhibit famous house that is in Puebla, in Mexico, and is the Uriarte house that is the first factory of Talavera in Mexico. So this project was very hard and also very long, but also we make us to reflect about what is the role of machines in terms of fabrication. And the last project is the Terra blocks. I also did it with my students. We want to recreate the adobes made by earth, but in this case, we want to recreate it by 3D printing using technology. So we 3D print a mold using double curvature geometries, a very complex geometry that you cannot use, made it perfectly by hand. And we do silicone molds, and with these molds, we just cast the mix of earth, and it's totally possible also to build and to generate a collaboration between tradition and innovation. This is the final exhibit that we did. And also we also create a second exhibition, but in this case we add different blue pigment that they came from ceramics, from the same project that I did last year. And in this case, we also study the kinds of assembly that these bricks can do and different kinds of accommodation of pieces, no? We use molds, silicone molds, and then we just create this little exhibition this year just to explain to the world that earth is also a very friendly material, that we can also use it in construction. So, and the wax project, we did it with Gensler, Mexico. In this case, Gensler, it's a very big office, actually it's American, and they asked us for a biomaterial, but this biomaterial should be transparent and should be replaced the acrylic panels or the glass panels because they want to be more sustainable. But in this case, we use beeswax just to do this panel. So how we do it, we 3D print a mold, and then we did the silicone mold, and then we just cast the beeswax. Why beeswax? Because beeswax is more sustainable and they have a really big compression strength, and then you can also put it in the interior or the exterior, and they have a really good water resistance. So in this case, we get the natural beeswax. We just demolish this in little pieces, and then we create the panels. This is the beeswax. This is how we get the material or the beeswax. Then we just add the beeswax. We just burn it in 10 minutes, and then we add a little stearic acid to get a better compression performance, and then we just cast it in the molds. In 30 minutes, you have a very good, sustainable, and healthy panels that they can replace acrylic. So this is the quantity of the panels that they are getting dry, and after 30 minutes, we get the final panels. So this is the final wall. This is a lattice. And right now we are respecting what they were asking for. They were asking for a material that can be translucent, that can be allowed to the light to pass through the material. So this is how it looks like. It's a very funny and beautiful wall, or lattice in the interior of their office in Mexico. And we are also replacing like a question about why we are using a lot of plastic and what is the plastic problematic in our beaches and our built environment. So Manufactura is, we have every day a dialogue with machines and humans. We do not ask for someone else to do our materials. We develop our material. We have a really directly contact with the materiality to understand how it before it performs. And then thanks to innovation and digital fabrication, in this case, with 3D printing, I am allowed to fabricate new materials and to give new alternatives for a sustainable environment. We also have this academia part that I can be able to impact different kind of communities that they are not in a school or of a university or an institute. For example, these guys are indigenous people from Purépechas from Morelia, and it is the first time that they have a contact with a machine. So for me, also, all the tools, not most, but most of the tools are also adapted in Mexico. So if someone told me that Mexico is not a technological country, they are wrong. We have a lot of capacity to do technology too. And also, the process is not totally automated. It's also sometimes the pieces have to be modified by hand. And also, for example, in the construction sector, only 96% are men and only the 3% are women. So we don't have diversity in our construction sector in Mexico. So that's also another thing that I want to promote, that also women are possible to be part of a digital fabrication process. So I'm also a teacher, no, in Universidad Iberoamericana. I'm the first teacher that I teach robotics in architecture, no, and we also learn how to control this kind of educational robots. I also teach in Universidad Anáhuac when I used to teach there. And in this class, I want to control and also to connect the students with materiality. We did different kind of experiments in different semesters, like with traditional ceramic, and then we 3D printed. Also, we use beeswax, no, natural beeswax, and we also compare how to build with a machine and how to build with a hand, no, with an analog process, no, with different kinds of application. So in conclusion, for me, digital fabrication is not a linear process. It's a totally like infinite loop between design and fabrication that they are totally fit by prototyping and empirical observation, but mostly for the material. You need to listen the material to start it, to design with this kind of materiality. And the question in our world right now is what happens when people are no longer part of the construction. We digital fabrication have a lot of advantages like new applications, new materiality, new optimal process, but also they have very big disadvantages as lost the human touch, change the labor relationship, and the most important, they make it visible the inequality in our society. So the European book said that in 2015, 2 million jobs will be replaced by robots. But in Mexico, our situation is totally different. No, more than the 60% of the national population are living in extreme poverty. Only one of the percentage of the population have more than the 30% of the GDP, no, in our country, and only 59% have access to internet. Not everybody have access to internet. So, for example, in the COVID, the education by the computers or by online were a very big mistake applied here in Mexico. It was not possible to educate our childhood. And this is very important. 70 of the percentage of the population live in self-built housing. Why? Because the government, there is a lot of poverty and the people are not allowed to pay the financial credit to get a house. So that's why this is the answer. They are building their house as their how to do it. So the question is, why does labor in Mexico is cheap? First, the education lack. Mexico has between 30 and 21st million people with educational backwardness. And the second, they have urgency to generate money. Only 4 than 100 Mexicans have an income more than 50,000 pesos. So Mexico is a manufacturing country. Why? Because 60.1 million people are engaged in the labor in the construction sector in Mexico. But in this situation, really risky situation without American insurance and having a lot of accidents, no, as I mentioned before. So in terms of company, only the 6% of the companies are using digital tools and 93% are using analog tools. There is not innovation in the companies in Mexico. And construction, in the construction industry in Mexico represent the fourth largest economic sector, and we don't have innovation. So robotic construction is not purely craft. It's a political, economical, a cultural, and a social topic, no? So here you can see how the government, for example, all the builders, all the people that are working in the labor, in the construction sector, are categorized as craftsmen by the government. So that's why if we want to replace it, we are replacing our cultural heritage. So they also have a very low income of 70,000 pesos per month. It's impossible to live with that. And they don't have diversity. 90% are men, just 3% are women. So this is the country that they have. And for example, Cemex, they just bring a really big cobot machine for 3D printing concrete, but the answers of the public was really bad. For example, they are asking about disemployment, the workers, they are going to replace my job, and the answer is no. The people here in Mexico, they are not really accepting the technology because the technology is not truly good communicated. So In total, today, energy and raw material costs are far from irrelevant. Labor costs will be increasingly affected by robotic automation. The question remains, can the revolution still be made by a printer costing more than $25? So automation does not distinguish between design and manufacturing or even economics. They want to replace the obsolete of the handwork. So my question is, what is the role of the robots in architecture? The book says that robots have been able to work beyond the human capability. But I want to close with this image. This is an artist called Stellark, and he said, there is no more human thing than technology. Because technology don't want to replace the human. They want to get the evolution of the human species, replacing and getting more capacities to the human through machines. So I did this exercise with my students that they just built one element by hand and one element totally digital, no, by machines. And I asked them, what is the most complex process and why? And this is the answer. So they just compare working with the body or working with the hands. And you really get surprised. They told me working by hand was more difficult than working with machines because they never work with their hands. They never have a contact with your body. But also fabrication is different because the communication with the machines is very different, but also the relationship with the material is very cool. So as Mario Carpo said, technology should not replace human contact. There cannot be community without a physical proximity. So I said digital fabrication have a lot of advantages like optimization, new materiality, but also working with our hands, working with our body, have the intuition, and the intuition is the consciousness of our body. So it's never clear where the human starts and the human ends. Thank you so much.
Thank you so much for this amazing presentation. I think it was very inspirational, and for many different groups, like we have multiple research clusters, but what you presented, I think connects with a lot of different ongoing research and at Stockman School. I wish you were here in person and we could also give you a tour, but this was amazing. So I'm gonna ask the audience if they have some questions. We also have a few people on Zoom. Let's start with the in-person audience. Do we have any questions from the audience? Oh, yes.
I had a question about the wood product that you produce with the furniture and how it's sun dried. I wonder if the weather and humidity impacts the production when you're doing that product.
Definitely. Like if the weather is very humid, then the drying process started to be longer and it takes more days. But if the sun and then the weather is very hot, then the dry also affects because it gets very fast and the pieces can also be broken and be damaged. So we have to be very careful about the weather temperature. So we also try to do this project in the same environment to not change, you know, the interior or the exterior temperature that we are letting these pieces dry.
Any other questions? Marcus.
Dinorah, thank you so much for your lecture. I just want to re-emphasize again, we wish you were here because I feel like we could have so many great conversations based on the different studios and the different research that we're doing. Can you talk a little bit about the development of the eggshells? You know, I feel like you're doing something where you're plugging in the digital capacity to engage the local. You know, the statistic that you gave about the eggs production in Mexico and how many eggshells you guys are actually sitting on as eggshell waste is really remarkable. But, you know, I wondered how you deal with the situation of the fragility of the project ultimately. You know, is there a temptation, for instance, to use some kind of reinforcing material like a little bit of concrete or a little bit of a polymer as opposed to the pure eggshell? Can you just talk us through the kind of contradiction of developing something like that?
Sure. Actually, this project is totally very interesting. I think this is the most the project that they have most impact in all the projects that we already did. We tried many different materialities in the last 2 years. So right now, this year, we also stopped a little bit and started to define which materiality works better and why, and to select just one materiality to start it to replicate it in different kind of scales or architectural objects. So when I did the marketing and also the impact of this material, I select the eggshell as the center material of manufactura. I didn't select the wood, I didn't select the other materials. But when I did the compression strength test, it was very sad actually because the compression strength is very loud. And this is what put me, to think over what we should change in the mix. So this mix, first of all, we started to do with Montserrat Ayala. She's an artist, but I think in terms of technical development of materiality, we need someone else that they can be more technically. So right now we are collaborating with Instituto Politécnico Nacional, that is the Mexican MIT, that's how we call this. And in this, we are collaborating with the chemists, with the chemical engineers. And these guys right now are developing a better mix. And right now we are not using concrete because we want to avoid this part. And we don't want to use construction earth. Right now we are using limestone. And this is something very new. I didn't publish it yet because we didn't finish this research. But right now we want to develop this new material because instead of using like 90% of eggshell, because the eggshell is very tough. You need to sanitize it, you need to clean it. And I clean it by hand. Actually, after the project, I get sick because of course I clean a lot of egg by my hands and by in a very not correctly infrastructure, and I get sick. So then I realized I need to be more careful and I need a more professional infrastructure to start to do this in a bigger scale. So right now, this is what we are working with. We're working to developing a better mix, and we're using limestone. And why limestone? Because it's very connected with our tradition. All the pyramids in Mexico, Teotihuacan, Mayas, and all the pyramids that you can see, Chichen Itza, Uxmal, whatever, they are made by adobe earth, but then they were covered with limestone. And it looks like a concrete. It's a very rough concrete. If you touch it, then you cannot broke it. So that's when then I was in Teotihuacan in the beginning of this year, and then I realized it. Then I visit Chichen Itza and Yucatan in Merida, and then I realized all haciendas, all the houses, and all the pyramids are made by this material. What we are not using because globalization and the same things that we have. So right now we are doing this future project that calls decolonizing concrete, no? So maybe in the future I can share it when we have a better infrastructure and a future results. But yes, we are working with this project.
Great. Thank you so much.
I have a question, if the audience doesn't have a pressing question right now. I don't know if you can see me. Okay, here.
Yeah.
You can see myself. So, I mean, I have tons of questions about the projects themselves, but I would like to ask more about like how Manufactura works, because I see that you collaborate with industry, you collaborate with academia, you also do workshops there. Like, how would you define it? Is it a studio? Is it like how? It's, I think, in between all of these. That's my question. Yes.
Yeah. Well, this is a tough question that I guess because Manufactura, I started as a factory, as a production factory just for commercial projects. But then when I get the opportunity to work with MIT, for example, I said, okay, maybe we can do a research project. And then I started to collaborate with academia, not just in America, in Europe, or also here in Mexico. So then I said, why I'm closing my boundaries and just working with commercial projects with industry. And what happens if I also can create this space as a research factory, not just as a factory, not as a production factory. So that's why we are working now. Actually, applying for a PhD in US. So that's what I want to exchange, no? Like in between academia. And I want to establish Manufactura as an official place to do research for academia. But in the same hand, on the other hand, I also want to do commercial projects, because commercial projects also, they are a little bit shorter, and also in terms of budget, are quite limited. More with collaborating with the Mexican companies. American companies are better, of course, than Mexican. But the good thing, you can get a very real application with a real client, with a real boundary. It's not the same like a PhD project that you have a budget and then you can just create a research and do a publication. Not in a real commercial project. You have other kinds of challenges like convincing a client or to convincing a company to invest in research. And one of the things that I want to also do here in Mexico, research is very bad. It's not making it. Nobody's doing research, just academia, because it takes time and it takes money. And I really want to create a perspective of research in Mexico that also the companies can be conscious of investing in research and not just investing in a product, because the industrial product also in behind of this, they have a lot of exploitation of the labor work. So that's why, for example, Nova Ceramic or Interceramic or all these companies, industrial companies, they have like the brick, they cost like less than 10 pesos. That is less than $1. So this is insane. Like how you can create a product that it costs less than 10 pesos because you are exploiting people. So that's why I want to also create a really conscious production factory with a new economy of production.
Great, great. I got my answer. More than what I was expecting, but amazing. Okay.
Thank you.
Any maybe last questions? Okay, then thank you so much, Dinorah. It was amazing to have you here.
If you want to contact me, you have the Instagram, no? You can contact me in my personal Instagram or Manufactura MX, no? Please follow us and follow our future projects because we have a lot of future things. Thank you so much for Penn State University. And for Marcus, please, thank you so much for making me be part of this. And hopefully my work on my research that is taking me a lot because I am financial. I don't have any academia behind me. I don't have any startup or any, how to say in Europe, these in ETH they call these little companies that they allows to academia. No, Manufactura didn't allow to anybody. I am Manufactura. I am working for this and it's a very passionate project because I really want to change the production environment here in Mexico. So please follow us and thank you so much for the opportunity.